By the way, if they give you like concentrations to start with, then that makes it even easier. You just have to plug those in. You don't have to convert to millimoles or any of that kind of stuff. You can plug in concentrations into this equation if they give them to you. You can plug in moles if they give them to you, or you can plug in millimoles. Whatever is the easiest to and the fastest to get to plug into that equation. This equation is the same, again, whether the buffered solution is made with an acid or a base. So in this solution, it's got ammonium chloride and it's got ammonia. So ammonia is basic. So this is a buffered solution that is made with a base. But this is still the equation you use to calculate the pH. So you have to plug in here where it says pKa, it's still pKa. You can't do pKb. You can't negative log the Kb value. You have to do what we've done before, which is to solve for the Ka value. And then if we do this, that would be a Ka value of 5.56 times 10 to the negative 10. That gets plugged in there. And everything else is the same. It's still the base over the acid. Okay, the only difference is that now the base is the main thing and the acid is the salt. So the NH4 plus is the acid part that gets plugged in, and NH3 is the base. Okay, that's the only difference. You've got to convert Kb to Ka before you can plug it into this equation. The equation still works. All right, now the last thing you need to be able to do, and this is the last thing we're going to talk about, is when you add stuff to buffered solutions, you have to be able to come up with the overall reaction that takes place in the beaker, which is kind of trickier than it sounds. You used to have to do calculations with this, but you don't anymore. So I'll let you guys write this down, but then we're going to talk about how to write equations for if you add strong acids to a buffer solution and if you add strong bases to a buffer solution. The reason why this becomes a little bit confusing is because you're taking three things and you're throwing them all together in one beaker. So I'm taking nitric acid, some volume of nitric acid solution. I'm adding it to a buffer that has formic acid with this formula and sodium formate. So those are three things there. And I'm adding them all in the same beaker. They don't all go on the reactant side of the equation. So I've got to figure out how to write this equation, what reaction is actually happening inside the beaker when I put them in there. So what you're going to do is you're going to go through each of these three things, and I mean, this is how I do it, is just to actually like draw a little beaker and put everything in the beaker that I have to work with and see how it all comes together. So when you put it in the beaker, you want to think about if it's going to ionize or not. So nitric acid, HNO3, is a strong acid, which means that it ionizes. So when I put it in my solution, it's going to break apart into hydrogen ions and nitrate ions. Okay, so in the beaker, you want to show how things break apart. Nitric acid breaks apart. Formic acid, it's not one of the strong ones I have memorized, so it's a weak acid, so it doesn't break apart. I mean, a tiny bit of it does, but mostly it stays together. So I want to write that in my beaker together because it stays together. Sodium formate, anything that's a salt is going to break apart. So Na plus and CO2H minus. Okay, so those are going to break apart into those ions. Now remember how in the last unit when we went through and we figured out if solutions were acidic or basic, and we crossed off ions based on what they were conjugates of. They were conjugates of something strong. You do the same thing here. Okay, so in this beaker, things that don't affect the overall reaction are the same things that didn't affect the pH in chapter 14. So nitrate ions being ions that come from nitric acid, so it is a very weak conjugate base, doesn't affect the pH. That gets crossed off. Sodium ions being conjugates of sodium hydroxide don't affect the pH and are not a part of this reaction. Okay, so we use the same cross-out rules. What I'm left with are three things, and those are the three things I need to fit together into one reaction somehow. You always want to start with what you added to the beaker. So it says that nitric acid is added to the buffer. So that means my ion that comes from the nitric acid is going to be on the reactant side of the equation. And then the other two things, I mean, it's kind of like a puzzle. You need to figure out which of these two ions will I add to hydrogen, or which of these two things, they're both not ions, but which of these two things do I add to hydrogen to get the other thing? Okay, so you can see that if I take hydrogen and I add it to the formate ion, then I get formic acid. So then you just put the reaction together like that. I have hydrogen plus CO2H minus, and it gives me HCO2H. So that's the overall reaction of what's happening inside that beaker. So whenever you're asked to do that, to write the equation, show how everything ionizes in the beaker, cross out ions that can cross out, and then combine, starting with what you added. Okay, so I'm going to do one more, just because when you add a base, it looks a little bit different. So, I mean, as far as writing this down, I mean, if you just want to write down these formulas, because these are the three things that are going to be in the beaker, and then we'll write that equation, and then we'll be done. Sodium hydroxide is strong, so it breaks apart and ionizes. The buffer is the same one as we had in the previous question, so I have formic acid, which is weak, so HCO2H, and then my sodium formate ionizes. Ions that cancel are sodiums in this case. Now, you always start out with what you added, okay? Sodium hydroxide is added, so I add my hydroxide ions. That's the first thing you write in your equation. And then I need to figure out where to put all those other things that didn't cross out. Okay, what you want to look for is you can't put two negative ions on the same side of the reaction. Okay, so I've got to take this other negative and I have to put it over here on the product side, CO2H minus. Which leaves me with this formic acid. So that's going to go over here because I have to add something to it, to the hydroxide ions. Now, that's what you want to look for first, is the charges. Same charges can't go on the same side. And then the other thing will pair up with the hydroxide ion. Now, this reaction is not complete. This is everything that's in the beaker, but also in the beaker is what that we don't have labeled here? Water. Okay? And you should include that specifically with this one. I mean, I guess you could include it in the other one too. But you should include it here because that hydrogen comes over here with the OH and forms H2O and leaves you with the formate ion. So that is the overall reaction.